Yeah, good afternoon, everyone. This is Collins Insuvga, and this is my AI project, which is all about digital identity fraud, which has been triggered in minds of different governments, countries, industries, and many organizations, where people try to forge to enter in different countries using illegal documents. They want to access organization databases, all data using they are using information which does not belong to them, and maybe and many others. So I've built or I'm working with this project so that we can eliminate these issues that are rising each and every day. So this an introduction. What is digital identity fraud? These are attempts to impersonate or calling yourself someone that you are not. So these attempts to impersonate users using fake biometric inputs like faces, fingerprints, voice recognition, maybe iris scanning, and many others. So what is the goal of this AI project? So to detect fraudulent attempts using liveness detection, anomaly detection, and adversarial defenses. So my project focuses on designing AI-driven countermeasures to strengthen biometric security against identity fraud. Understanding these vulnerabilities establishes a motivation for our research. So this will be achieved through methods like biometric input capture, feature extraction like CNN for images, spectral temporal for voice and fraud classification. So the biggest question was, can computer think? So basing on some of the theories like weak AI, this simulates cognitive tasks. It executes algorithms to detect fraud. The system's intelligence is task specific, meaning it can do only one task or specific tasks, but not all. If you have built a model to do us at a given task, meaning it is going to do that very task, not any other task. So our AI fraud detector does not understand fraud, it only classifies input based on learned patterns, meaning it does not understand what it's doing, but it can use the patterns or the data set on which it trained to give the output. So when we talk about the strong AI, this would require consciousness, understanding, and intentionality. So our system lacks the above listed facts. It just predicts the outcome according to the trained data sets, but it has no consciousness or it does not understand what is not happening or using the surrounding environment for its prediction or outcome. So when you talk about the Chinese room argument, high accuracy does not equal to understanding, meaning this AI model may detect that this person is not the same person that we registered or is in our database. That one doesn't mean that the system or the model it really understands what it's doing. So the current AI systems do not understand fraud, but they analyze statistical patterns based on the trained data sets and patterns on which it was built. So when you talk about the Turing test, on this one we talk about, can AI understand maybe something that is happening in a conversation? Yeah, specifically that. So could AI behave indistinguishably from human fraud analysts? Performance alone does not imply conscious thinking or doesn't mean that it understands what is going on or what is taking place. And the system's intelligence is narrow and specialized. It's not broad, it's just narrow or specialized, meaning it is built to do something, not general. So in biometric fraud detection, the AI can outperform humans in spotting replay attacks, but unlike humans, it cannot reason about intent or adapt beyond its dataset. For example, a fraud analyst may suspect a new attack strategy. AI will fail if not trained with new data. Meaning, if those people who are trying to sneak into the systems maybe get a new trick for entering into the system, the AI may fail to detect that if it's not trained on retrained on a new data set so that it can capture that trick. So it's also domain limited, meaning it's effective in biometric fraud detection but cannot generalize outside this domain. Then we talk about learning and memorization. So all AI models learn statistical patterns and correlations from the training data and detect micro movements, text artifacts, and voice anomalies, but lack counterfactual reasoning and cannot explain why something is fraudulent. Meaning, if someone is scanned or the face or someone's face is scanned, and it will recognize that maybe this is an image, it's not real, but it cannot explain or it cannot tell us why that one has happened. No, it will not. But the AI model learned. So our AI system trained on dataset must generalize fraud attempts in the new environment such as low light security cameras or mobile phone biometrics. So then we talk about memorization. It occurs when an AI its memorization occurs when AI overfits training dataset and cannot generalize. This project highlights the importance of validation across varied fraud attempts to prevent overfitting to narrow datasets. So, proper model training and validation ensure accurate fraud detection. So when you talk about how Guardian's 8 intelligences, I found out it only on my project of fraud detection, only two applies, which is logical mathematical intelligence and interpersonal intelligence, which is weak. So when you talk about logical mathematical intelligence, feature extraction, anomaly detection, and pattern recognition. Basically, those are the features that I'm using in my project, and it really applies in logical mathematical intelligence. The AI system excels in mathematical reasoning and logical pattern analysis. AI leverages logical mathematical intelligence to detect anomalies in biometric data. For example, detecting tiny micro movements in facial images and subtle spectral anomalies in voice to flag fraudulent attempts. So subtle means something which is hard to detect or describe. Then we talk about interpersonal intelligence, which is we say modeling trustworthiness in biometric verification. The AI can model likelihood of fraud in a way similar to how humans judge trustworthiness. For example, it is weak because the AI does not actually understand human intentions or emotions. It only stimulates decision making based on the data or the trained data set. So another question was, could computers ever think? Then based on different theories also, the first one was connectionism and classical AI. So when I first talk about the classical AI or symbolic, AI uses rule-based logic to model human reasoning. AI uses rule-based logic to model human reasoning, meaning This AI is only trained, this model is only trained by a person to do human reasoning. Philosophically, replicating human cognitive abilities may not equal to conscious thought, meaning that model that you have trained will give you the results, but it won't know what is happening. Yeah, it won't tell what is happening. Then connectionist AI, such as neural networks, simulates cognition through distributed processing. While our CNN-based fraud detector can identify anomalies, anomalies means something which differs from the original, or it may be something which is a bit different from what is normal. It does not create new reasoning strategies. It actually thinking AI would adapt dynamically to a new fraud method without retraining, something our system can't do yet. Meaning, if other fraud techniques are identified, or we got to know how maybe someone is trying to enter into our system without being the member of that company or the system. So we have to retrain that model so that that model can learn the new fraud methods so that it can detect them. But other than that, the system won't adopt that automatically. Meaning, we the still the model can't think beyond that, so that it can dynamically adopt to new frauds without retraining. So fraud detection models often use connections approaches to learn new patterns. So despite advancements, AI does not think like humans. It processes data and identifies patterns. So when you talk about ethical considerations, so we have anonymization and encryption of biometric data for privacy of the data owners. Meaning here we are not supposed to be exposing the data from people that we are going to use as our training data. Testing across testing across demographics to avoid bias that will affect the fairness across that will affect fairness and accuracy of the predicted results. So meaning we have to train our model based on different versions of maybe people, different colors, different maybe environments, so that our model cannot get biased about different aspects. So explainable AI for decisions by professions about the detected frauds, meaning the professionals or the AI model builders are responsible for explaining whatever the results of the AI model. So in my AI biometric detection, so our inputs can be face, can be voice, can be fingerprints. So the method that you are going to be using for extraction of that data can be feature extraction, classification using machine learning models, liveness and anomaly detection. Then the results, because supposed to be having our confidence accuracy using log stroke AUC matrix for real world data sets. Then in conclusion, according to my project and the main points of coverage where we had questions like, can computers think, or can computers ever think? So in my conclusion, I therefore say AI stimulates aspects of thinking but does not truly understand. Yes, because it can follow the patterns on which the data set had been trained, and produces the results accurately, but does not really understand why that result was produced. Future AI may approximate thinking in narrow domains, consciousness remains and solves. Yes, future AIs may approximate narrow domains, but consciousness remains unsolved, meaning that AI model that you have trained, it will never and ever know why that thing is happening or why the results are being produced. Thank you so much for listening.